In this video, we're going to talk about factoring trinomials by foiling. Another way to factor trinomials that don't have a leading coefficient of 1 is using a technique called factor by foiling, or the trial and error method. This is the process of arranging all possible factors of the first term of the trinomial and all possible factors of the last term until we obtain the correct outer and inner parts. So I've kind of given you a brief diagram of this below. Okay, so let's factor completely then. Okay, so first thing, is there a greatest common factor I can take out of all of the terms other than 1? In this case, no. The leading coefficient is not 1, so we're going to try this factor by foiling method. So the factors of the leading coefficient of 9, that's 3 times 3 and 9 times 1. Factors of the constant, which is 4 times 1 and 2 times 2. So I'm going to start with 9 and 1. That means it's going to be 9x and x. Now, we need to determine signs also. Because a constant is positive and the middle term is positive, we know both of these signs are going to be positive also. All right, so let's try 4 and 1 first. So check the outer and the inner. So that's 9x plus 4x. It's 13x. That doesn't work. So let's try 9x and x again, but let's switch the 1 and the 4 around. So checking the outer and the inner, we have 37x. That does not work either. So let's try 9x and x again. 4 and 1 we've done with this case, but we haven't done 2 and 2. So let's do plus 2 and plus 2. Outer and inner. That gives us 20x. That does not work. So we've exhausted all the possibilities of 9 and 1. So now let's do 3 and 3. So that's 3x and 3x. Let's do 2 and 2. Outer and inner. We get the middle term, which is 12x. So that means this is factorable by 3x plus 2 times 3x plus 2, which is the same thing as 3x plus 2 squared. This is what is called a perfect square trinomial. And all that means is the factors are exactly the same. Okay, let's go to the next example then. Okay, first off, is there a greatest common factor I can take out of all three of these terms other than 1? And that's a no. The leading coefficient is not 1 with 3 terms, so we're going to try again this factor by foiling. So we want to write out all the factors of 21. Well, that's 7 times 3 and 21 times 1, and then 2 times 5 for 10 and 10 times 1. Now, I'm going to try the factors that are a little bit closer together. So I'm going to try 7x and 3x before I try 21x and 1x. Now, the signs. The constant is positive, but the middle term is negative. So it's got to be a negative times a negative gets me a positive. But when I add two negative numbers up, I get a negative also. Okay, so let's try 5 and 2 first. Check the outer and the inner. Negative 29, that does not work. So let's try 7x and 3x again. I'm going to switch the 2 and the 5. Do the outer and the inner. This matches up with the middle term here. So this factors as 7x minus 2. And 3x minus 5. Okay, let's go to the next example then. First off, is there a greatest common factor I can take out of all of these terms other than 1? In this case, there is. I can factor out an x. When I factor out an x from each term, I'm left with 12x squared plus 5x minus 2. Now, we have 3 terms, the leading coefficient is not 1. So again, I'm going to try this factor by foiling. Well, I'm going to put factors of 12 over here. and then factors of 2. Again, I'm going to try the factors that are the closest to each other first. So I'm going to use 3x and 4x. Now, we need to determine signs. Well, because the constant is negative, that means one of the factors has to be negative and the other one has to be positive. So I am going to try 2 and 1. Let's do the outer and the inner. Now, notice the right number, the wrong sign. So if that situation ever comes up, it's a very simple solution. You keep the numbers exactly the same, but you change the signs. Now, let's check. Now we have the right number and the sign. Now, your final answer is the x that you took out as a greatest common factor, and then these two other factors also. Okay, one other example I want to take a look at. First off, is there a greatest common factor I can take out of all the terms other than 1? In this case, there isn't. The leading coefficient is not 1. So again, I'm going to try this factor by foiling technique. So all my factors of 3 are 1 and 3, factors of 5 and 1 and 5. Because the constant is positive and the middle term is positive, I know my signs are both positive. So let's try 3x and x. And then let's do 1 and 5. So we need to check the outer and the inner. That does not work. So we're going to try 3x and x again, but I'm going to switch it with the 5 here and the 1 here. Check the outer and the inner. And that does not work either. Now, the problem is I've exhausted all my possibilities because it's only 1 and 3 and 1 and 5. So what does that tell me? Well, this is not factorable. This is what is called a prime polynomial.